So this is technically not 4.3. This is 4.1, 4.2. So let's rewrite that, make that a 4.2. It's not supposed to be 4.3. 4.3 is when we actually start solving quadratic equations using factoring methods. Anyway, we have this whole worksheet. It's two-sided to do. Let's do an example of each. Which one would you like to see? 1 through 4. Pick one. Number 2. Okay. So we begin with the vertex, always, to graph. Now, notice that they give you the vertex formula right here. There's one thing I kind of dislike about this formula. I am so used to writing the negative up here on the B. But if you want, you could leave it out there in the front. But anyway, here's your formula. X equals negative B over 2A. You need to identify your A, your B, and your C value. That way you could plug it in. But remember, I always recommend using parentheses instead of the B and the A. So negative parenthesis over 2 times parenthesis. And we're going to plug in that B value of 4 and the A value of 1. So when we do the math, we end up with a negative 4 up on top over 2 times 1, which is 2 on the bottom. So we know that we really have a negative 2 as an answer. And what is this negative 2 really? The X value of your vertex. So ladies and gentlemen, negative 2 is the X value of our vertex. Bless you. So we have the X value of our vertex. We need the Y value. What do we do to find the Y? Plug it in into the original function. Now I'm just going to circle my answer and draw an arrow up here. That way I could rewrite this entire equation. Now normally it says Y equals, right here it says f of x. It's the same thing as Y. It's just function notation. So let me rewrite it exactly the way it is. F of x, but since I will be plugging in a negative 2, this would be the appropriate notation. Instead of f of x, we would put f of negative 2. All that says is that I'm plugging in negative 2 in place of x. So let me rewrite my function. Instead of x squared, I put parentheses squared, plus 4x, plus 4 parentheses, plus 3 at the very end. Okay, so there's my function. I am plugging in that negative 2 in place of x. Doing the math, negative 2 squared, that's positive 4. 4 times negative 2, that's a negative 8. Bring down the plus 3. 4 minus 8, that's negative 4. Negative 4 plus 3, that is negative 1. So there's my answer. What does that answer represent? The Y value of our vertex. So our X value is negative 2, our Y value is negative 1. That is the most important point right there. Okay? We will have a test on Friday, and I will most definitely ask you to find the vertex over and over on many different quadratic functions, okay? So let's graph that most important point. Negative 2 on the x, negative 1 on the y, which is right here. What's the very next thing that we should do after drawing the vertex? Axis of symmetry. I think we're pretty much pros at graphing parabolas already. That axis of symmetry equation is x equals the x value of your vertex, which happens to be negative 2. And that's what they want for you to write right here. The axis of symmetry is x equals negative 2. Okay, so we have our vertex. That's what they wanted for the first part. We have the axis of symmetry. And now it's time to come up with more coordinates so we could actually graph this parabola. So it says to make an XY table or pattern. So it's totally up to you, whatever you feel more comfortable with. And I would always, I like to go with the pattern all the time. Even if I have to modify it, I like to go with the pattern. So let's write down the pattern, 1, 1, 2, 4, 3, 9. And I always like to put it in a little cloud because this is what you need to have memorized in your head. And that is the pattern from the vertex. So you need to think, is this opening up or down based on the A value of positive 1? It's definitely opening up. So I am going to go 1 over, 1 up and put a dot right there. I'm going to go back to the vertex, 2 over, 1, 2, 4 up, 1, 2, 3, 4, put a dot right there. And then go back to the vertex and go 3 over, 1, 2, 3, 9 up, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm right on the edge, but I could draw it because it's right there on the edge. Of course, we're going to map these coordinates over to the other side of the axis of symmetry. And we're going to draw our parabola through those coordinates. And you will get tons of points for that on the test Friday. But in addition to that, we have so much more information that we're going to state. So what is the Y-intercept? Well, it's crystal clear that that's a Y-intercept right there, right? It crosses right here. But I might ask you for the y-intercept even without the graph. All you have to do is set x equal to 0. So if you go to your original equation, set x equal to 0. To find the y-intercept, set x equal to 0, and your answer will be the c value, which is 3. So what's the y-intercept? It's 0, 3. Everybody should write that down. Again, your y-intercept will always be the c value on a standard form quadratic trinomial function. How about max or min? It has a minimum. From left to right, it's going down, going down, going down. Then it reaches a minimum, and then it goes back up. So yes, it's definitely a minimum value. So let's circle minimum, and let's state what that minimum value is. That's right. And you could even put y equals -1, right? Yeah, -1 is totally fine. You could just say the minimum value is -1, or you could say the y value is -1. Either one's totally fine. Or you could even, if you wanted to, rewrite the vertex. The minimum value is -2, -1. But I would say y equals -1 or just -1. The domain, that's absolutely easy. X equals all real numbers. The range, just as easy. Y is it, there you go, greater than, because this is your minimum value. It's going to be greater than your minimum value or equal to your minimum value. Or another way of I say it is it's greater than or equal to the y value of your vertex, because that is the minimum value anyway. And that's it. Oh no, there's one more. State the x-intercepts. Now, ladies and gentlemen, sometimes the x-intercepts are nice values. Like right here, you could visually see where it crosses the x-axis. Right? Here's 0, here's -1, -2, -3. So where does it cross the x-axis? At -1 and -3. So those are the x-intercept values. Okay? -1 and -3. Now, that's stating them visually, and that's all I want you to do on this worksheet, to state the x-intercepts visually. In the next section, we're going to be finding x-intercepts algebraically, right? They're not always going to cross at nice locations like at -3 and -1. Right now, on this worksheet, if it happens to cross like right here, then you would just say -1, 2, 3, 4. It's between 4 and 5. You could say about -4.5, right? So you could actually give approximations. And there are some that you have to give approximations on. Anyways, that's the front side. Let's flip it to the back side. On the back side, I want to do number 6. I picked number 6 because the a value is not 1, so we have to modify that pattern. And of course, you could use an XY table, but I want to modify the pattern. Anyways, let's find the vertex. Let's first start by writing the vertex formula. X equals -b over 2 times a. And of course, we're going to use parentheses instead of the b and the a. We're going to identify that the b is -8, the a is 2, the c we don't care about, it's not in the formula. So we have -8 right in the parentheses. We have 2 down here. We end up with a -8, which is really a +8. It's a +8 over 2 times 2, which is 4. And 8 over 4 is really 2. 8 divided by 4 is 2. So I have the x value of my vertex. That x value is 2. I still need the y value. So what I am going to do is plug it into my original equation. Y equals 2 parenthesis squared minus 8 parenthesis plus 4. All I did was rewrite the function, but instead of x's, I put parentheses. Why is that? Because I know x equals 2, so I'm going to take that 2 and plug them right into the x's, right into the parentheses. Doing the simple math, let's go with exponents first. 2 squared, that's 4. I still have the 2 in front. What is 2 times 4? That is 8, okay? And then when I go -8 times 2, that's -16, and then I bring down the plus 4. So I really have 8 take away 16 plus 4. And of course, all of this could be done on the calculator if you wanted to. 8 take away 16 is -8. So we have -8 plus 4. -8 plus 4 is -4. And that is the y value of the vertex. So our vertex is 2 on the x, -4 on the y. So from the origin, go 2 on the x, -1, 2, 3, 4 on the y. Let's put a dot right there. Whoops. There we go. Next thing to do is to draw your axis of symmetry right through that vertex. And the axis of symmetry equation will be x equals the x value of your vertex, which is 2. Now, of course, we need more points, right? So you could go, if you wanted to an xy table. and you could plug in numbers that are on the same side of the axis of symmetry, right? What would be the easiest number to plug in? 0 is definitely the easiest, right? If I plug in a 0 for x, if I plug in a 0 for my x's right here, what's my y value going to be? The c value, right? Remember that? So that's like finding the y-intercept. Set x equal to 0, and it's going to be your c value. So when I plug in 0, I get out a 4. I'm just showing you how you could make an xy table. Or, if you wanted to, you could stick with the pattern. I want to write my pattern right here. My pattern is 1, 1, 2, 4, 3, 9. However, I need to modify it by the new a value of 2. If you look back up at your equation has an a value of 2. So I need to modify the outputs by the a value of 2. Okay, so because a equals 2, you need to actually multiply the 1 times 2, the 4 times 2, and the 9 times 2, giving you a new pattern. And that new pattern is 1, 2, 2, 8, and 3, 18. 3, 18. So if you wanted to use a pattern, you're going to have to modify it according to your new a value. If not, you could stick with your xy table the way we just did right there. Plugged in a 0, pulled out a 4. And you could plug in more numbers like 1. So if we did want to plug in a 1, I might as well do both. Plug in a 1 into both of these. I don't recommend doing this in your head, but I'm going to do it right now because you guys could catch my mistake if I do make a mistake. So 1 squared is 1. 2 times 1 is 2. 8 times 1 is 8. 2 take away 8 is negative 6. Negative 6 plus 4 is negative 2. So when I do plug in a 1, I get out a negative 2. So let's go to the coordinates 0, 4. 0, 4, 1, 2, 3, 4. And also 1, negative 2. 1, negative 2. Now let's say I wanted to use the pattern 1 over 2 up, 2 over 8 up, 3 over 18 up. Okay, so from the vertex, 1 over 2 up, right? Which would be right there. Go back to the vertex, 2 over 8 up. That would be right there. So either way, I'm just showing you both ways, using an XY table or using the modified pattern. Either way, you'll be able to graph this parabola. And once you get a couple of coordinates, you'll be able to map it over to the other side of the axis of symmetry, and you'll have your perfect parabola right there. Let's answer anything else. The Y-intercept. What's the Y-intercept? That's the C value, right? When you set x equal to 0. So the Y-intercept is what? 4. Let's say 0, 4, because that'll give us the exact location. How about the maximum or minimum value? Is this a max or is this a min? There's a minimum value. And what is the minimum value? Negative 4. Okay. And we could say negative 4, or we could actually say y equals negative 4. Simply the y value of your vertex, right? The domain's x equals all real numbers. The range, y is, because it's opening up, that would be a greater than or equal to that y value of your vertex, negative 4. And check this out. State the x-intercepts, approximate if necessary, right? Because where does this parabola cross the x-axis? Here's 0, here's 1, here's 2, here's 3. Wait, no, I'm sorry, that's not 3. 3 is right there. That's 4. Okay, so where does this parabola cross the x-axis? Approximately 3.5. And over here? Approximately 3.5 and 0.5, right? 0.5 and 3.5. So you don't have to be exact. Later on, we will have to be exact, okay? So we're going to say it's important that we do this. Put the squiggly equal sign. That's saying it's an approximation. If you put equals, that'd be wrong because it would have to be exact. So we said about 0.5 and 3.5. Now that's definitely not the correct answer. It's just an approximation, okay? So that's about it. Okie doke. You are going to do the rest. The answers are posted on the back wall right there in the classroom. Have these answers posted on the back wall, and we have both sides posted. There's the other side. And of course, they will also be uploaded as a PDF onto Edmodo. Please let me know if you guys find any mistakes. Okay, so I do want to mention one more thing. We just finished this one right here. This is looking at the answers. But remember, guys, the graph of any function really represents the infinite amount of answers that exist to that function, right? So if I were to ask you to plug in the number 1, 2, 3, 4, if I were to ask you to plug in 4 into these x's, what would your answer be? And you could do this without actually plugging in. So the input 4, the x value of 4, 1, 2, 3, 4, would give you the y value of 1, 2, 3, 4. So 4, 4 is a coordinate. That means that if you plug in 4, you get out of 4, right? So the graph itself is really an infinite amount of answers that exist to the equation. So if I were to plug in 4 for x and do all the math, I would get the answer 4. Okay, just to let you know. Okay, a graph really does represent the infinite amount of answers that exist to an equation.